Good evening. So there you heard the voice of John Scully, our much cherished BTS annual dinner organizer since many years. But with the housekeeping announcements done, I'll start today's proceedings. George Dulkis is running a bit late. So I'm Divik, I'm one of the ex-chairs of BTSYM and currently serving on the ITYM steering board whilst representing the UK. And today we're welcoming John Nicholas from National Highways, ex-TfL. A lot of you might already know John, but I've got a bit of a bio here. So John is National Highways tunnel manager for Hindhead, Roundhill and Southwick tunnels. He's also the asset need manager for Southeast and the operations strategic lead for tunnels. So after gaining his BEng from Camborne School of Mines, John enjoyed a number of roles in tunneling, pipe jacking and micro tunneling, up and down the east coast of Ireland to CTRL, with periods working on rail tracks, southern region and with tube lines. Finally settling down for well over a decade into road tunnel management through a variety of roles with TfL, including tunnel operations and maintenance manager, and then contract manager covering the Dockland road tunnels, and finally tunnel manager, which included Silvertown for a little while. Strong believer in knowledge sharing, as evident from today's initiative. John is not only an active committee member of the UK Road Tunnel Association, but also one of our key irregular attendees but staunch supporters of the BTS. Regardless of the irregular attendance, we finally cornered him today for this much needed lecture, which has been in the works for a while. So the stage is all yours, John.
Thank you, Divik. Thank you all for coming along this evening and for joining us today. Sorry, dude in the cupboard, would you mind putting my presentation on, please? Sorry, thank you very much. Sorry. I'm John Nicholas. Thank you very much for that, Divik, for going through that a little bit there. Let me just pop us onto it. So tell them what you're going to tell them, then tell them, then tell them what you've told them is a little strategy that I've been told over donkey's years. So I think the best bet really is to run into what we expect of road tunnels. Contrary to popular belief, this isn't how we normally operate our road tunnels, but it does give you a flavour for what we normally find in a brand sparkling new one. And looking around the room, there are probably one or two people in the room who might have had a little bit to do with the design, construction, or possibly even the turning these into maintenance. Because obviously the BTS is the sort of organisation that will be contributing to those sorts of endeavours. But rather than subjecting you to at flight and in kilometres an hour rather than miles an hour thrill spills via Red Bull and far too active music for this time of night, this is a scenario that we actually designed tunnels to avoid.
Despite the horror they'd been caught up in, those trapped by the tragedy were grateful their situation wasn't far worse. 400 people fled the flames and spent hours stranded without their cars at the tunnel entrance. Tom Steinfort was with them.
Many were unsure why they'd been told to leave their cars, but the magnitude of the catastrophe was soon apparent.
You've been evacuated to this point because there's been an accident in the tunnel.
A small community was set up at the entrance to the Burnley Tunnel, complete with catering and entertainment. But most could only stand stunned as they learned of the chaos they'd escaped.
Looking to the side of me, I saw a guy in a truck and we looked at each other, and after that second explosion came, we just thought, yeah, let's get out of here.
These were the lucky ones who lived to tell of their escape.
Panic, didn't know what was going on. I thought, got to get out of here. So I parked the truck up and people were just jumping out of cars left, right and centre. And just made a move, get out of there.
We all just left our cars and walked. And then somebody said to go up some steps. We went up the steps, the smoke was coming, but then no, down the steps, and we ended up walking out.
But amid the panic and trauma, there were also great stories of camaraderie.
There's an old lady there that couldn't walk, so I put her in her stroller kind of thing, and pushed her out of the tunnel.
Chairs were brought in for those who needed help, while children were left to amuse themselves. There was little people could do about the interruption to their journeys.
Just arrived from Sydney.
Not the ideal arrival.
No, it is not, no, especially.
So there we go. Clearly someone's travel plans interrupted there, which is the sort of thing that we're looking to avoid as part of our design, our operation and our maintenance of our road tunnels. So just quickly, the best thing to start with is how do we define a road tunnel? So under the European directive for the minimum levels of safety for road tunnels on the Trans-European Road Network, and look at a couple of people in the room right now, particularly one, Dave, who's looking straight at me. I can imagine that rolls straight off your tongue. You could probably quote the number of that directive as well, but it defines it as over 500 metres of length, forming part of the turn, and it's measured down the centre line of the tunnel. It's an enclosed structure for 500 metres or more. I will be referencing the Design Manual for Roads and Bridges, which is the DMRB, which is a National Highways document that is owned by our colleagues in Standards and Engineering Services, maintained by them throughout this. So CD 352 is the Design of Road Manuals standard that we apply, and it defines a road tunnel as a subsurface highway structure enclosed for a length of 150 metres or longer, measured along the centre line of the soffit. So just to give you a bit of an idea, these are the types of structures that we're referring to today. But it's first worth going back to first principles, which is why do we need a tunnel? So in reality, the need will be generated around economic growth. It's the potential for making that connection for people, providing a service to communities on two sides, generally of a physical obstacle, like a river, like a mountain. So in the case of road tunnels like Dartford, we obviously have the River Thames there, which is the obstacle, and we therefore have the Dartford River crossing tunnels, which is obviously supported and supplemented by the QE2 bridge. In terms of through mountains, well, we've got Mont Blanc and the Alpine tunnels as well. So, you know, it's providing a more direct link rather than a more arduous and circuitous route, which is obviously much longer, much more timely, much more energy consumptive, if that is a word. I clearly have been spending far too much time around project managers because I'm now making up words. But basically, it's too much effort to be doing that. So if we can create ourselves a shortcut, either through or beneath that physical obstacle, it then creates that more ergonomic sort of opportunity for growth on both sides. And what I have observed personally from those sorts of assets being provided is that you tend to see those opportunities being realised really very quickly, and actually the land gets portioned out pretty quickly as soon as the announcement of a tunnel is made, because people want to start considering where those links can be established and what potential for growth for their organisations they can provide and support. So some of the key questions that we need to be considering when we are going to, because we're the types of people that go building tunnels and providing them to these communities, is how we're going to pay for it. So are we going to do a PPP arrangement or a PFI with tolling, user charging, or do we do a free one? What types of traffic are we going to prohibit? What types of traffic are we going to allow? The types of traffic really are a major consideration for what types of facilities we need to be providing within that tunnel. How do we fight fires within it? And fire is actually our greatest hazard or risk for tunnel operation. Clearly that Burnley tunnel incident that I showed, which was the second video, clearly illustrates what the impact can be on tunnel users. I will be sharing this with Divik and colleagues from BTS. So if anyone wants to have a look, there are embedded hyperlinks that can take you through to the full video if you would like to knock yourself out in your own time over that. But how do we keep the tunnel open to traffic? So how do we establish maintenance contracts for it? What future capital investment do we need to consider? At what stages do we need to be considering refurbishments? And then there's a key document for me, which is how do we establish what our minimum operating requirements are? So what's the minimum level of asset availability or systems availability to provide a safe tunnel for the tunnel users? And then moving quickly on to how might change be managed throughout the life of a tunnel. So as tunnel builders, which many of you are no doubt, you'll be designing and building and delivering and handing over into operation and maintenance a structure that has been designed for at least 120 years worth of service. So as an operator and maintainer and renewer of that structure, I need to know that I've got enough money there to be able to deal with it throughout its 120-year lifespan. I need to know or have an idea around how technology is going to change. I also need to have a think about the way that how I'm going to support our customers on their journeys through that asset as well. So a key one for us at this moment in time is obviously the changing types of propulsion systems for the vehicles that are using our tunnels. Clearly back in the day when Blackwell Northbound was open, horse and carts going through produce a different type of emission when they catch fire to a battery electric vehicle. So I will just leave it there. And then, of course, there are many more considerations. So I'm not going to drive you mad with that. And I'm not going to go into presenter mode because I can't see half of what I'm up to, and that will also drive me potty and make me mumble even more. So just going into it, something that's nice and contemporary for us, Silvertown Tunnel. There are probably more people in the room right now that know more about this job than I do, but I was there in the early days and loved it. But the need for it, when it opens pretty quickly, will be to eliminate those delays that had been acknowledged for decades at the Blackwell Tunnel, particularly after tidal flow was removed, and you know it was a regular on every breakfast news sort of bulletin coming out of LBC and everywhere else. It was good and topical, and hopefully with the provision of Silvertown Tunnel, that topicalness will die away soon enough, and it will no longer become such a regular feature. Lower Thames Crossing, clearly that has its needs set up as by almost doubling the road capacity across the Thames east of London, easing congestion at the Dartford River crossing, which is a significant proportion of the need or the requirement for building that tunnel. Lower Thames Crossing is proposed to be a Category A tunnel, which under the carriage of dangerous goods, let's say, regulations, means that anything is allowed to be transported through it. Whereas the Dartford River crossing is Category C, which means that certain hazardous vehicles are permitted to travel through, but under escort, which is one of the main reasons for the delay. And we've got a person in the room here who has direct experience of being able to manage that and the people around it too. So if you want to catch up with him later on, can I encourage you to do that? Then of course we've got the Stonehenge Tunnel down on the A303 that has been kicked around the Wees for quite a number of decades now, and I'm just looking around the room and seeing these people that are smiling and nodding quite nicely, because I think we've all seen it, but it's got the same sort of a thing, you know. It's realising those benefits. It's leaving a lasting legacy that's going to benefit the local residents. It's going to attract tourism. It's going to meet all of these needs. It's going to sort of make it much more amenable, and it's going to smooth the traffic flow, because obviously it's a single sort of lane in each direction at this moment in time, through an area of absolute wonder, with a roundabout on each end, and it's probably not the best arrangement, bearing in mind the volumes of traffic that are using it and wholly dependent upon it, and the communities that are in the immediate area of it. But then we move on to the cost of having to undertake these endeavours. And this is effectively me pulling some figures out from Tinternet, as it might be. So I've used Limehouse Link, as it was reported the cost per linear metre of road for that tunnel was in the construction. And I think I used another one as well. It could have been Hindhead or something like that when I was working for TfL. But they're just indicative. So effectively, you'll have this huge, big cost up the front end of the contract, which is your construction and delivery of a road tunnel, which is current and it meets all contemporary standards. And it's nice and shiny, you've trained everyone, and you now you get a minister out who cuts a ribbon, and it's open to traffic. So you've had this massive piece of expenditure. And then over the next decade or so, you have operational interventions. You might renew this, that, and the other. A couple of cameras will fall off, or whatever it could be, but you deal with it. And then at a certain period of time, generally around about 20 to 25 years, you'll have to have a significant renewals intervention. So, a refurb, for old money sort of stake, a renewal of a number of assets within the same sort of program or period of time. And that's reflected by those peaks that you can see there that I've highlighted as refurbishments. But the key point that I'm really getting to here is that all tots up over time. So you've got your initial huge outlay, but year on year on year, you're going to be spending out on maintenance commitments, and that's going to be to your M&E kit. And by M&E, I mean your ventilation system, your fans, your electrical distribution systems, your switchgear, your transformers, your cameras, and all of your operational technology that supports it, so your PLCs, your servers, and all that sort of kit. You need to keep on top of it. You need to keep them secure. You need to keep them safe and reliable and operational at all times, and particularly around your operational technology, your servers and your IT kit, because those need frequent interventions and patching and software updates and all that sort of thing. And they're core to the function of your tunnel as a holistic system that provides a safe route for all of your customers. So we need to make sure that, you know, that when we are looking at a tunnel as an option, that we've accounted for the cost of this over that 120-year lifespan. It is one of those where other people in the ICE will tell you that you know, if you're talking about cost of construction of a linear metre of road, you add a zero if you want to sort of like put it on a viaduct. You add another zero if you want to make it a bridge, and then you add another couple of zeros per linear metre if you want to make it a tunnel. Yeah, I don't really want to say too much about that rule of thumb, but I don't think it's too far off the mark. But this is the big hole that we're creating. Going back in time, Rotherhithe Tunnel, an absolute beauty. We love it dearly, particularly people at TfL or that have been at TfL. And we have, sorry, 1 second there. So we've got Rotherhithe on, as I'm looking at it, the left-hand side, and Blackwall Tunnel on the right-hand side. I don't know if you, yeah, exactly the same for you guys too, with a load of people with contemporary, I think is the best way of putting it, PPE, which includes a sort of like a court-length sort of jacket with a top hat. So we've only really changed a little bit in terms of style. It still needs to be appropriate for site, and no doubt the footwear is too. Nowadays we've got things like cut and cover tunnels. We have an example of a similar style tunnel here down on the bottom left-hand side, which is more or less a profile that I have for my tunnels, which are Roundhill, Southwick and Hindhead. The box structures are generally the cut and cover structures, and they're normally a little bit shallower in terms of the profile and depth below the surface. The more rounded ones are clearly further down, and then of course we get into the board tunnels, which dealing with the different types of ground conditions that they're presented with, it is the safest way of constructing those structures and keeping them there for that 120-year lifespan. A couple of the assets that we have inside of there that provide safety systems or support the life safety systems of the tunnel include the emergency crossover doors. Generally, when we construct a road tunnel, we try not to have a single bore anymore. We try to go for 2 bores because you can run one in each direction. It just seems to make sense. There are a couple of tunnels that are still kicking around that we run contraflow or bidirectional traffic in them, so that includes tunnels like Rotherhithe. Saltash down on the A38 has 3 lanes, and they operate a contraflow system down there that is operated by the Tamar Bridge company on behalf of National Highways. But effectively, if we were to have a post-it note to do a design on today for a road tunnel, we would no doubt put down 2 round circles and connect between the 2 of them with cross passageways, so that if we need to make an intervention from one bore, we can do it from the other bore and put people in a place of relative safety. So once we've got those holes, we've got those structures in the ground, what happens next? What kit do we need to keep people safe? So in CD352, which, as I said earlier on, is a design of road tunnels standard for national highways, it gives us a couple of nice little tables here. So the one on the right-hand side, which looks like a log chart or something like that, which those of you that might have done surveying at uni and now forgotten all about it will be far too familiar for you. But it sort of like gives you a number of different categories of tunnels, which is dependent upon the length of the tunnel, measured down the centre line, as we said earlier on, and the estimated average annual daily traffic flow for that tunnel. So to give you a little bit of an idea around what that looks like, Blackwall Tunnel, northbound is around about 55,000 vehicles per day, southbound is around about 53, 54. Well, it was a couple of years ago when I last looked at it, and that is their annual average daily traffic flow. They're AADT, effectively they're at full capacity, both of those tunnels, which is the reason or the need for Silvertown to be constructed. But on the left-hand side, that gives you a list of assets and systems that you need to provide to those tunnels, to provide effectively their life safety systems. So things like crossovers, like emergency telephones, the installation of them. You might think that that's a bit of a basic requirement or a basic provision, but we need to tell people that they have to have them, or else it happens to become a saving. And then moving into the main system. So everything that we have in a road tunnel is powered by electricity. There's no getting away from it. So we need to think about 2 independent HV incoming supplies. This has proved an issue with tunnel builders in the past, where they haven't been independent enough, and we've ended up with regional outages from district network operators that have impacted on tunnel operations. Tunnel lighting. Traditionally, we used to have sons and tubes, sodiums or tubes, fluorescents, but now with energy efficiency becoming a more growing, because actually no, it's a bare basic need nowadays and requirement. We're going to LEDs. It's as simple as that. It's a better quality of light. You get better visibility inside of the tunnel bore than you ever got with sons, because they just made everything orange and looked like an 80s smoker's bedroom. But in a nutshell, everyone's going to LEDs, lower electricity consumption as well, so they're really a good deal. And we can also operate them using lower voltages, which makes them safer for our operators. And of course, if you can make them brighter by remotely fluctuating the lighting levels, you can make them last longer. You can also increase the lighting, and during its operational state with the tunnel open to traffic, which means that you don't need to send someone in as frequently to wipe the lenses down. You just boost the lighting and make it just a little bit brighter inside of the tunnel bore. Ventilation systems, in normal operation, we just leave them to tick over, and then when the atmosphere starts building up and starts becoming a little bit smuggy, or we're not content with the mix of emissions that are within the tunnel bore, we might kick it into a lower level just to clear any of those pollutants out. But predominantly, a ventilation system is installed in a tunnel as a system for life safety. So when we get a fire, we want to clear those products of combustion as quickly and effectively as possible. And those products predominantly are whatever the gases and fumes and particles are that are being emitted, and heat. And running the ventilation system as much as possible, you're dissipating both those heat, that heat radiation, but also all of those particles, gases, and everything else as well, diluting it and creating a space downstream, upstream, I can't remember. Towards your point of entry that is clear of air, and you're sending your typically you're directing those products of combustion away and with the flow of traffic towards the exit portals. Closure systems, they're a great idea. Effectively, we want to stop more people getting into a tunnel when we've got an incident in there, so we want to have a way of reliably being able to shut it without causing an additional hazard or risk to tunnel users. So there's a whole way of designing that to be as safe as possible as well. And then a monitoring system. So how do we initiate all of these responses? So CCTV, we've got stop vehicle detection, or SVD, which we've had installed at Hindhead Tunnel and running quite nicely for us for the best part of a decade there. But additional systems, we've got the whole list that you can knock yourself out with, and if you so want, and I'll make sure that this comes through to Divic later. And just to give you a little bit of idea around what we're looking at there, so we've got some emergency evacuation direction signage. They normally sit unlit unless we want to be telling someone which direction they want to be going, or else there might be another way, which is we just want to tell people to be getting out of the tunnel bore, so we'll light both sides of them. So they can be directional. It depends on how it's tied into the evacuation system. This one that we've got in the middle up on the top is basically a message sign. So we might be telling drivers as they're driving through the tunnel that there's pedestrians in road, that stay in lane, contraflow in operation, animals in road, crisp packet floating down the carriageway. And funnily enough, crisp packets are one of the things that we do know set off SVDs. So all those sorts of obstructions, how reflective they are and how they interact with the systems, is one of the key considerations for us as maintainers just as much as operators. So we need to make sure that we keep those tunnels clean, swept and clear of obstructions, particularly on the immediate approaches, so vegetation clearance and that sort of thing, and being mindful of what our planting schedule is going to be around the portals too is a key design consideration for us. Then down on the bottom left-hand side, we've got a tunnel, a typical access area for a tunnel service building. The bottom middle is a typical view from within a cross passageway. So we've got assets that you can see in there. We've got a CCTV camera so we can see you that you're in there. We've got the alarmed crossbar doors, which basically alarm back to a control room. We've got an emergency roadside telephone, which also goes back to a manned control room. And really, once you're in that environment, you are in a place of relative safety, and we know that you're there. And then on the bottom on the right-hand side, those are some ventilation fans that had been sent away to be refurbished and were just waiting for a lift back into the tunnel bore. In terms of the organisational structure for a road tunnel, there's normally an administrative authority, and this is taken from the directive, which then translates into the regulations, which then is translated for us into the DMRB, as I said earlier on. But it's the administrative authority that appoints a tunnel manager, and the tunnel manager then designates a tunnel safety officer to support them through that function as well. There is also an inspection entity and a technical approvals authority as well, and Tassos at the front there is part of our technical approval authority. Then we get into maintenance. So maintenance is just principally, it's just asset management. It's making sure that you look after your kit, you keep it operating and functioning for as long as possible. And that is just a typical bell curve up in the top on the left-hand side for asset management that I think many of you will be far too familiar with. And on the top right-hand side, that's a brand new ventilation fan that was stuck in probably about 3 weeks before the photograph was taken. But schedules and the frequencies at which we undertake these interventions, those are contractual mechanisms. So we would engage a maintenance contractor for a period of time to carry out those duties, and they go from dailies to weeklies to fortnightlies to monthlies and all that sort of crazy frequency, depending on what the task is. So it could very well be that we want them to do a daily run through just to make sure that all of the tunnel areas, the tunnel bores themselves, are clear and free of obstruction, that they're clean, that they've been checked over. And it depends on what facilities we have there as well. So the types of facilities that we might have is a control room. And if you've got a control room, is it staffed 24/7? Or is it one of those where you need to keep it clean and available for the emergency services if they need it for a rendezvous point or for one of their, we call it silver meeting, but Joint Emergency Services Interoperability Meeting, JESIC, I can't remember, command control. There we go, Silver Command effectively. So an incident management centre for those people that are strategically responding to the incident. So there might be a need for that. But depending on the tunnel, depending on what systems are available to them, depending on the length and the communities that are around it and the economy that it serves and supports, will depend on what facilities are there, which will then have a knock-on impact onto what the maintenance schedules are. On the top right-hand side there, those are the fan stacks, the old fan stacks in Rotherhithe Tunnel. So that was a beautiful photo that's taken by a colleague of mine quite a long time ago. And the photo beneath it shows vent shaft 4 and south vent shaft in the Millennium Dome. So if any of you watch EastEnders, and as they start the dum-dums and focusing out, there is a hole in the dome, and that is a vent shaft for Blackwell southbound. And I never told you that. Then moving on to more schedules there, we've got some monthly schedules, we've got some more cleaning. Those clearly are Blackwall and from some time ago. So really good fun there. But when we're doing these maintenance activities, excuse me while I grab a drink. While we're doing these maintenance activities, we've got to think about our customers and where are they going to go? They want to complete their journey. The reason why we built the tunnel is to connect these communities, to enable growth, to enable people to be moving around. So as an outcome of us closing our tunnel to those people that are reliant on us for their journey, we need to send them somewhere else. So we have to consider what diversion routes we're going to be using. The diversion route example that I've got down here in the bottom left-hand side is the one for overheight vehicles for Blackwall Tunnel, which effectively sends them away from Blackwall Tunnel, which is a Category E tunnel under it's the ADR regulations, but effectively it translates into English as the carriage of dangerous or hazardous goods. And a category A means that anything can go through it, is the way that I remember it. A category E means everything nasty is prohibited. So Blackwall is a category E, and its alternative or diversion route is via Dartford, which is a category C, which means it's halfway between the two of them. So it permits some vehicles and some goods to be carried through it, and it permits some vehicles and goods to be carried through it under escort, and it completely prohibits others. So that's the reason why Blackwall can send goods to Dartford. Oh yeah, it's also got a larger height limit on it at Dartford and a more generous width restriction at Dartford as well, I believe. But all of this is managed from a control room, or not, as the case might be. So there are different types of operating and managing the traffic operation through a road tunnel. And this will be one of the tasks that's defined through its design. So whether or not it's going to be a wholly autonomous tunnel, whether or not it's going to be monitored and operated as one of a number of tunnels, or whether or not it's going to have its very own dedicated control room. So a couple of examples that we've got of that could very well be, what's the one in Hertfordshire, John?
Oh, which one, Hatfield?
No, the other one that's run by...
Command Centre from South Mims.
No, the other one. Bulldog.
Oh, Bulldog.
Bulldog. Yeah, so we've got Bulldog, which effectively is allowed to run itself. It is set up. Yeah. It's wholly autonomous. When something goes wrong with it, it sends a signal to a control room that is operated by police officers, and they do something. But for all intents and purposes and functions, it looks after itself, and then people go out and check on it regularly. So that's the first example. We got the lowest level of it. It's not particularly long. It's not got particularly too many assets in it. It's pretty Spartan in terms of a tunnel. And it's not got too many systems in it. It does the job. Then we move up to the next sort of level. We then move into the realm of TfL's road tunnels, where they operate 11, 12, 13, 14, however many tunnels they're going to be operating from it shortly as soon as Silvertown comes online. But they have a number of tunnels that are operated from a central control room, and they're all connected. So there is a resilient network connection between each one of those, and it ties in, and you have a number of very competent operators that monitor not only the tunnel's life safety systems, their operating systems, their electricity supply and all that sort of thing, but also on a huge video wall much bigger than this thing here, they also monitor traffic flow, and they're looking for incidents, objects, obstructions, brake lights predominantly, and odd-looking traffic flows. And then you end up with a dedicated control room. So Hindhead is a great example of this, because when Hindhead was constructed, there was a fabulous idea, which was that this is out in the middle of nowhere. It is all on its own. It isn't within immediate and easy reach of another control room where it can be operated from. There are no other assets around it. So it needs its own dedicated control room to be able to manage effectively fires, incidents, and all that sort of thing. So it has its own dedicated control room. It's got a couple of tunnel service buildings that support that. One of those has the main control room within there, and that really is the other example of it. A collaborative hybrid approach to that may be Saltash Tunnel down on the Cornwall side of the River Tamar. And that is operated in conjunction or collaboration with the bridge, because of the close proximity of the bridge and the tunnel. Effectively, if you were going from Cornwall into Devon, you would go through the tunnel straight onto the bridge, and the transition between the two is only a couple of 100 metres, if that. But they have to actively manage the traffic there, which is one of the reasons why the tolled bridge takes that dominant operational function there. But effectively, the reason why we're operating these tunnels either so actively or so passively is due to the hazards that we're expecting to be realised there. So things like power outages, road traffic collisions, spillages, fires. Those are the types of incident that either can be dealt with through automated systems, or they require the additional vigilance that is provided by a Mark 1 eyeball and an operator with a supervisor in a dedicated control room to carry out those sorts of functions. Prohibited vehicles and their intrusions into road tunnels is an issue that we have that is particular to road tunnels, that is not encountered in rail tunnels. In a railway tunnel, you everything you take into that rail tunnel, you know what it is. You have all of your materials, you will have permits, they will list what your fire load is. The train operating companies know that the fire load that each train has is probably a maximum, and the fire safety people will know how this is calculated, but your fire load that you bring into that tunnel on a train is engineered down to something to around about, 10 megawatts sort of thing in terms of the fire, whereas a typical family car nowadays is probably anything between 8 and 12. So that sort of like gives you an idea about the types of fire loads that we're dealing with. And when you're considering that we have 55,000 vehicles per day travelling through Blackwall northbound, with around about 91% of those being cars, with about 1% of those being motorcycles, which have a fire load of something between 1 and probably about 5 megawatts, potentially, depending on how much fuel they've got in them and the materials that are built into it, and whether or not it's a Honda Goldwing or it's a little sort of 50cc, which is prohibited anyway, or it can go up to a goods vehicle. And when we're talking about goods vehicles, their loads, generally we start off from around about 20 megawatt fires, rapidly escalating up through to the next category that we'd look at dealing with is probably 30 to 35 megawatts to 50, and then from there on is 100 megawatt fire, which is really quite a nasty sort of fire. And the way that that's consisted of, it depends on what's on the trailer. Now, when you think about monitoring and dealing with fires in road tunnels, one of the main reasons why we ventilate towards the exit portal and not the entry portal is when you think about how a vehicle's set up, the propulsion system's at the front of it. So if you blow all of your products of combustion away from the front of the vehicle, not towards the rest of the vehicle, you're going to be moving all the heat and all of those gases and everything else away, so it won't grow back towards the rest of the vehicle. I mean, we've all done barbecues, I'm sure of that. And if you fan it, it's going to grow. So if you start blowing your fire back over the rest of the vehicle is going to catch. So that's one of the reasons why we blow it away towards the exit portal. And yep, down in the bottom there, nice and bold, fire is really is the main hazard that we're always thinking of. So those products of combustion, which can, predominantly it's heat, it's also those sort of airborne particles, but it's also the stuff that's left on the ground. It's also the damage that's done to the carriageway. It's the smut and it's the particles that adhere to the inside surfaces of the tunnel wall that we need to deal with afterwards. It's also the damage, the facilities that we've got. We'd be losing a section of the tunnel and all of those mechanical, electrical and life safety systems within that portion. So we want to be absolutely certain that we can design the tunnel and all of its component parts of those life safety systems, so that if one of those events was to occur, we could already have a plan in place to be able to respond to it and recover our operation of that tunnel in the soonest possible time. And it will be more than just simply, swabbing out the sumps or something like that and doing a quick bit of resurfacing. It would mean things like, complete and thorough electrical testing, making sure that we've done functional tests from the control room, from each fingertip of an operator through to an endpoint device, to make sure that when we press the button, the fans do what we're expecting. They blow forwards rather than back, or whatever it might be. And when we want to boost the lighting can actually boost. So it really is, the recovery phase from those types of incidents is a significant portion of the design and a lot of the work that we do in normal sort of road tunnel operation planning and maintenance planning as well. And maintenance particularly to make sure that all of those systems are up to scratch. They will always do their job. And we've got regular inspections that we commission people to do, so that we know and we're confident that we know what the condition of those assets are. And if we need to make an intervention, like a replacement, like to replace a whole system or a single asset, we're in a confident position that we know what we need to be doing for that and keeping it in a good condition. And here's just a couple of horror shots there. We've got a couple of road traffic collisions. Up in the top right-hand side, I believe that used to be a TVR. It had been picked up by the owner around about half an hour before it caught fire as it was driving through the tunnel. There's been a number of incidents like that where vehicles, particularly down at Rotherhithe, where we'd had quite a large staff presence of engineers going down doing inspection checks and that sort of thing, might have been in the open cut approach and stopped a vehicle that had smoke or steam coming out of the engine compartment. And when they on one particular occasion, they asked the driver, "What are you doing? Do you know your car's on fire?" He said, "Yes, but I phoned the AA hands-free, and they've told me they'll meet me on the other side of the tunnel." So, so customers do the unexpected, I think, is probably the nicest way to put it. The photograph below the TVR was a VW Combi that had been bought by a group of Kiwi lads who were engineers and saved up for a number of months, bought themselves a Combi, fitted it out. They were going to go tour Europe on it. They managed to get from one part of South London to the approach of Blackwell northbound, I think it was, on the south side, heading towards France, so not very far at all. Electrical fault, and that was it, end of the journey for those chaps. And in the bottom on the left-hand side with that Battenberg liveried Met Police vehicle, that was a transit van that was stopped by the duty police sergeant or traffic sergeant who was sat on his motorbike at the time, and he noticed a transit van that was riding a little bit low on its rear axle. So he pulled him off onto the inspection overheight ramp and said, "Can I have a look in the back?" And the guy willingly opened up the back. He was from a church group or something like that. Opened the back up, and as the sergeant had a peek over the top, he moved a carpet that had been placed over the top of a fridge, and noticed a number of gas bottles, and he clearly thought that it could potentially be a terrorist type incident or something like that, and immediately there was an exclusion zone established. They removed over 90 gas bottles, I believe, of varying sizes that had all been decommissioned, and then the hole that was drilled into them to decommission them had been welded back up again, and they were going to be shipping them off to a West African church donation. Sorry. And that'd be me doing something or another. I've got no idea. So enough war stories there. Live exercises is the next bit. The main pictures there, including the green spill down at the bottom left-hand side, are from a very imaginatively named live exercise in the Rotherhithe Tunnel called Gold Top, which was one of the first ones that I was ever involved in. And as you can guess, it involved a milk spillage, which the tunnel safety officers in the room will tell you is a particularly sort of hazardous environmental type of spillage, which is really not very nice for fish and that sort of a thing. But it doesn't really do anything for us, which is one of the reasons why we generally pick a milk spillage as a scenario for an exercise, because it gives you that opportunity to test your response to spillages, but you don't have any of those atmospheric hazards that you need to put anyone into respiration apparatus for to respond to it. And we all love a live exercise because it gives you the opportunity during the planning phase to go through as many scenarios as possible. So you can, if you want to, land a jumbo jet in the portal and have to deal with the evacuation of all of the people that have been boarding that plane however many minutes ago. But you can do that because it's exercise land. But when it comes to a live exercise, you need to be dealing with the nuts and bolts generally of what systems you've got in the tunnel, how can you test them most effectively, and what outcomes are you looking for? So is it going to be a training outcome for the emergency services, or are you looking at the performance of your life safety systems and ancillary systems as well in the tunnel? Or else are you testing how they work together? So the emergency services, do they know how the ventilation works? Do they know how noisy the vent fans are? Do they know how noisy your loudspeaker PA system is? Can they use their radios to talk to each other when you've run your ventilation fans up to full and you're trying to shout over the PA's messaging to tell people to get out of the tunnel? And it's only until you run a live exercise that people actually get the understanding that, yes, it's very noisy, and yes, a loudspeaker PA system is really very intrusive as well. So there's that bit there. Sorry, let me just see if I can skip through, because I think I've accidentally killed my laptop. There we go. Next one there. So really it gets down into incident management and exercises, and straight away that is the directive, which translates down into the regulations, which then we include within the DMRB standards that we have. So there really is that line of sight all the way through when we were part of Europe, that requirement coming through, getting translated into our regulations, which I understand still remain part of UK law, which then translate into our standards. And it is worth recognising that the directive actually towards the bottom end of the main part of the document says that these are minimum safety standards for the Trans-European Road Network tunnels, And we suggest that all other tunnels adopt them as a minimum standard. So, you know, this is sort of like the lowest bar of safety for road tunnels, is what's in the directive, according to the European community. So, you know, it really does make sense that we as road tunnel operators, maintainers, as builders, recognise that this is the lowest level of the bar that we should be skipping over. So, you know, we should always be striving to make sure that we can provide something that's better, more efficient, enables us to recover from incidents, because incidents will happen. So we want to try and narrow down that recovery period and our responses as far as we can. So there's just some legislation and best practice there. And I think it's around probably about 18 months ago, I had the privilege of coming along to one of the NEC events somewhere upstairs, which was full of the great and good of the BTS tunneling world. And clearly quite a number of really great people there. And I spotted this tiny little, there was a little photo montage of different bits of tunnels from all over the world and how it was important. And I spotted that little bit there, which is the memorial for the Mont Blanc tunnel fire. And that for me was really poignant. So we had all these other disasters up there, you know, around civil engineering world and that sort of thing. But that was the one that actually struck a chord for me, because that directly tied to the directive that we have for the minimum standards for tunnels. So, you know, it's having that line of sight and recognising that people actually died, and lots of them as well. And as an outcome of those fatalities, you know, we now have to make sure that we provide those minimum levels of safety as operators. So just quickly buzzing through, I've got a couple of summary slides, so I'm really sorry for that. So in summary, a road tunnel connects people, communities, opportunities, and enables the economy to grow. They should be designed and appropriately funded with the users in mind. Changes in technology considered for at least 120 years of safe operation. Maintenance, monitoring, good communication, and relationships with responders and competent staff significantly aid the safe operation of a road tunnel. And don't underestimate the extent of delay to traffic resulting from a shut tunnel. If you shut it, generally what's happened is people have become accustomed to it being there. And when a road tunnel is closed, they don't know where to go. So your impact on those communities in the immediate vicinity is actually quite stark. There is a societal need to be met to support future growth and resilience. And there's a couple of examples here that I just randomly picked off of Tinternet, which is a great source of knowledge, but also of misinformation too, as we all know. So Norway continuing with its ambitious program of tunnel construction, including the recently opened, I'm not going to say that because I will embarrass myself, but there is a link there if anyone would like to have a look at it. New Zealand is considering a new tunnel under Auckland Harbour. Australia obviously has opened up the main part of the WestConnex tunnels there. And for those of you familiar with Professor Arnold Dix, there is a link to his Strayhenge project down the bottom there, which is obviously, on a lighter note, a little thing that he was using as part of his promotion for one of the World Tunnel Congresses last year, I believe it was. And because no man is an island or no person is an island, as we should be rephrasing it nowadays, and that was the original intent, I just wanted to quickly pop up a little slide here to say thank you to everyone. And first of all on that is to all of you that have joined this meeting and of the BTS young members for having me tonight, and particularly Tassos for blooming well stitching me up on this, and Divik too, because I'd actually forgotten about Divik mentioning this to me around about 4 years ago, I think, on the first occasion, saying, can you please come along, and we ended up being caught up in COVID times for the best part of 2 and a bit years. But I will add you before I share this presentation, don't worry about that. So that effectively is me. Does anyone have any questions? Right, we've got a couple of microphones.
Next one. But yeah, if you've got any questions, please raise your hand and we can entertain a few questions.
I'll start with a question. Tom McGowan, thank you very much. Very interesting talk. I thought it was interesting to note there's tunnels that were for horses and now they're for cars. Do you see in the next 120 years tunnels being reused for other things? And as a second part of my question is, what do you think of Tesla putting automated cars in small tunnels? And will that have any impact on the way you operate your network potentially?
Okay, so you've got a couple of really good ones there. So who has had a walk around the Tower of London recently? Anyone in the room? Right, so you know down towards the riverfront, you know where the entrance to the tower is? There's a circular sort of building with made out of like a yellow brick sort of thing, right? So that, I think, was the first tunnel underneath the Thames.
First circular tunnel underneath.
It was indeed. So, but it was one of those where they had a really extraordinary system, and I really wholeheartedly encourage you to have a look about how they transported people, because they used a vacuum system to actually pull people in like specific carriages through there. Absolutely amazing. I've got no idea how or who came up with the concept, but it's fabulous. It's now a cable tunnel. Indeed. So, you know, tunnels will always be repurposed for something or another. They've always got to use the structure, so long as it's there, so long as it's sound. There's no reason why you can't make use of that facility. One of the biggest challenges that we've got is trying to figure out, when it comes to the structure, is what's the condition behind your primary lining, because the only way you've got of telling it is probably to drill a hole through it. But I'm you know, with a number of colleagues, you know, around National Highways and the wider tunnel sort of like manager sort of community, we've got a real interest in trying to determine how we determine the condition of our primary tunnel lining and what's happening to the ground behind it. Because if you're getting water coming through your lining, there's always the danger that you're going to be having fines and all sorts of other bits and pieces. So long as you've got it there for you design it for 120 years, you know it's going to be there for even longer. Blackwell northbound, it's open to traffic in 1898, something like that. So when it had its centenary, yeah, I was a bit younger than I am now, sort of thing. But you know, it is one of those where so long as you've got that facility there, you can repurpose it, you can refunction it, and just continue its life. Your question's a bit of a funny one, because you know that Tesla tube thing, it was a great gimmick. It got everyone's attention for quite a long time. There's been a couple of spin-off sort of projects as well. I know there's someone down in Surrey, isn't there, who's promoting a tunnel excavation sort of thing using nanobots or whatever it could be. But that's all sort of like spinning off of the same sort of concept of, you know, tubes with doing things in it as automatedly as possible. It could be a hyperloop. Sorry, that was what you're talking about, really, wasn't it?
I think what I meant more actually was their concept of single bore tunnels that could only fit one tiny car, that you could never, an individual wouldn't be able to drive inside of it, but the idea is that the computer can. So
I love it as a concept, I really do, but as a person who is and it comes back to that first tunnel that I was talking about earlier on, as a person in there, we're reliant on whatever that vehicle is to make it from A to B. And if it doesn't, what happens next? So if you've constructed a tunnel that is limited to the envelope of that vehicle that is actually designed for the open road, and the only way in or out are through the doors, which won't open, because you're inside of a vehicle that's just designed to fit the vehicle, not the doors open. How do you get out? How do you recover? How, you know, and if you end up with a number of vehicles together, how do you safely platoon them through that section of road? You know, there are a lot of complications. And in fact, we're engineers, so our role isn't to say no, it's to figure out a way of overcoming that and adapting whatever technology we've got, or looking outwards to try and figure out what solutions there are that could be available to help us to do it. So personally, I won't ever say no to anything like that. I just think it would take someone who has a lot more time on their hands than I have at this moment. But if I was given the right motivation, I could probably come up, oh yes, and a rather meaty post-it note pad and a couple of pens, I could probably come up with something with a few people, because, as I said earlier, no person is an island. So, yeah. One of the key things that we've got at the minute that is a burning issue, there are a number of groups that are looking at it, is obviously around thermal runaway for battery electric vehicles particularly. And it is worth considering that batteries are in an awful lot more than just Teslas. They're also in an awful lot of hybrids and that sort of thing. So the potential for thermal runaway, if you have that type of battery pack in it, is wider than just the ones that have got the focus and all of the press. And there is a fantastic fellow called Professor Paul Christensen, who is leading a number of groups that are looking at the response to this. And check him out on LinkedIn, have a look at his posts. He's absolutely fantastic. But the research that he's working on, in collaboration with a lot of other people that are operators of roads, emergency services, so that they can safely respond to it, is absolutely fantastic. So it is something that is a very hot topic. Excuse the pun. It's not really a pun. It was a slip. But anyway, sorry. Dude in the blue shirt next to John. Sorry, I don't know your name, mate. Yeah, you put your hand up. Oh, you're just having a stretch? Okay, that's fine. Okay, go for it.
Yeah, William Ebbett. I work for ScanScore on HS2 at the minute. So I remember Boris Johnson was talking about building a road tunnel from England to Ireland, or Northern Ireland. Is there ever a length if the road tunnel becomes too long, particularly if you have to ventilate your combustibles?
See, there are a number of road tunnels, and I think the thing is that once you get over a certain length of tunnel, you shouldn't really be thinking about it just in terms of road. There is this whole sort of drive towards multimodal sort of thing. So like railways are being considered, normal railways are being considered, cable routes, all sorts of other bits and pieces. So the Gibraltar, no, it isn't really Gibraltar. I'm talking about the Morocco to Spain tunnel. It has been something that's been mooted for a fair number of decades. I don't think it's been sort of like on the discussion cards for a while. I saw it a few months ago, but it certainly hasn't been kicking around, I think, for as long as the Channel Tunnel was, which basically was going to be our plan to invade Napoleonic France, or Napoleon's opportunity to invade us. But, you know, it is one of those where, you know, connecting through under, physical obstacles is something that I think is something that we will be looking at. As I said a minute ago, it's down to us as engineers to figure out ways of making it happen safely. Yeah, at this moment in time, I would look straight to the standards, because that's how we can safely manage and deal with and respond to, based on what our contemporary knowledge of risk and hazard is. And we can do that from a place of relative comfort. We can still push the boundaries with it, don't get me wrong. Silvertown have done that. Lower Thames Crossing, through their preliminary design, they've looked at doing that as well. Everyone as part of construction will look at seeing how far you can push the standards, but you'll be doing that with a balance. So there's always checks and balances with these things. But really, like I said, we're engineers. It's our jobs to be ingenious.
Thank you very much. I'll ask a question.
Go on.
So around systems engineering. So with the rapid changes in data analysis and their role in systems and sort of control systems,
yep.
When one is specifying a project today that's going to be constructed in about 15 years, for example,
yep.
How does one come up with the right system choices?
With great difficulty is a short answer. No, and I'm not lying to you about it either. It's been an issue that we've got at the moment, and we're encountering it in national highways, because we've got Tassos and his colleagues that are in SES who own our standards. Then we have got the technical specifications for the operational technology, which effectively covers off those network systems that you're talking about. And the ones that we're operating at the moment are quite vastly out of date. So we're going through a rewrite project right now. Good, I'm glad that that's done that, so I can unplug that. But you can, but you can't, sort of thing, if you know what I mean, because technology is rapidly evolving. So it's not really evolving, it's revolutionising. It really is at quite a rapid rate of knots that this sort of thing is changing. And a lot of that is to do with the way that networks are configured. The software that software firmware and all that sort of stuff that runs it is also configured, because what tends to happen, and I'm casting dispersions, I know it, but we get a base sort of level of software which might have a couple of holes in it, and then we build on top of it, and then we build on top of it, and then we build on top of it. But quite often what happens with these software platforms as they're built is that those original base defects and faults